Hello everyone. So today's topic will be uh, momentum, conservation, and about friction. So first, if we recall the last class, we have three laws. That is the law of inertia, and what was that? That was if there is no external influence, that is force, then an object will be in its own state forever. That means if something is at rest, it will stay at rest. If something is at motion with some constant velocity, so it will be moving forever. So that was the law of inertia. The second law was about how to change that state of any object. So to change the state, we have to transfer some momentum. So someone has to transfer some momentum to that object, so that irrespective of that inertia, it can change its state and it can go, or it can, or some moving object can comes to state rest. So that means that thing which is called the influence or the transfer rate of what you say momentum is nothing but your force. So force can be written as the change of momentum by time, or mass into acceleration, simply. And the third one we have come across was that every action has equal and opposite reaction. So this, if we apply some action, that will create equal and opposite reaction. So that will create equal and opposite reaction. Though the center of action is different, so that they don't cancel each other. Okay, so that was the whatever we have talked till now. Now coming to the next thing that we are talking about is momentum conservation, or conservation of momentum. So let us write conservation. Now conservation means something which does not diminish easily. So it conserve, that means it stay there. Okay, so conservation of momentum means momentum is not destroying. So how it is happening? Now we know that when we want to change the state of any object, we have to give some momentum to it. That means momentum has to be transferred from some system to another system. Let's say I want to change the state of B system by using A system. So A system has to give or transfer the momentum to B system. So if you take the whole thing as the total system or universe, so we can see that momentum only can be transferred, it cannot be created suddenly. And also it conserved. Okay, in a system, in a whole system, it conserved. So that means if we talk about some kind of example, like striking a ball in the wall. So in that case, you can see that let's say this is the wall, and I have a ball, and the ball is coming and striking to the wall, and again it's going back. So if the mass of the ball is m, so in that case this was coming, approaching with a velocity v, and also it is going back with a velocity v. It can be possible when our wall is taken to be extremely or perfectly rigid. Okay, so we know that momentum is written as generally we express in terms of p, and that is nothing but your mass into velocity. Now you can see that velocity is a vector quantity, so momentum is also a vector quantity. So momentum is a vector quantity. So if it is a vector, so it certainly have some it has some what you say direction. So you can see that when the ball was coming towards the wall, it is going into this right direction. So my initial momentum was, so initial momentum pi was in this case mv, and I can take that the direction towards the right side is positive. So I can assume, you can assume like negative also, but for now I am assuming that the right side is positive. So when it is going back, so this is plus mb when it is approaching the wall. Now when it is going back from the wall, that is it is going away from the wall, in that case everything is same, only the direction of velocity is changed. So my new direction is now, my new momentum is now minus mb, because it is going the left side. So the change in momentum I can write as pf or pi, that is the initial was, so we will subtract from initial, minus pf. So if we put it, we can see that this is minus mb, so it will come twice mb. This result is very what you say useful, that momentum like change of momentum is like positive. So that means and like the momentum of this ball has changed like twice mb in amount. So that means this change somebody has given, right? So who has provided? This rigid body has provided. How he has provided? Through the reaction force he has provided. Okay, now so that is how the like initial momentum and the final momentum like is conserved in such a way. Okay, now in this case we have only one object, and we have seen how we can calculate the change of momentum. But let's say we have two objects, like this is my objects a and this is my object b. Now a object with mass m1 was coming with mass like with velocity v1, and b object was going with velocity v2, whereas the mass is m2. Now if my v1 is greater than v2, that means the like a object is coming faster, okay, and moving faster with respect to b object. So that means a object will catch b object after some time. So when it will collide with b, so when a will collide with b, what will happen? It will transfer some of its momentum to b, and so the velocity of a also will be changed, and the velocity of b also will change. So after collision, let's say the this what you say a has a new velocity. Let me draw nicely. So a has a new velocity, let's say let's say this one I am taking u. Okay, so that will be better. So this is u1 and u2, and now the new velocities are v1 and v2. So the what you say conservation of momentum say that the initial total momentum, so the total initial momentum is should be same as the final total momentum. So that means if I calculate the initial momentum, so if I calculate the initial total momentum, which is how much, which is the m1 u1, that is momentum of a object, and m2 u2, which is the momentum of b object, that is, so this is the initial momentum, And what is your final momentum? Your final momentum is m1 v1 plus m2 v2. So this is my final momentum. So according to the conservation theory of momentum, pi should be equal to pf, means the total momentum of the system should be same. So now if we so that means what? That means my pi minus pf is equal to 0. That means what you say, the total change of a system, the total momentum of a system is conserved. So the system here consists of a object and b object. In that case the total momentum is constant. Okay, so it is not changing. Whereas if you calculate only the momentum of b or only the momentum of a, in that case that will not be what you say constant, because due to a, because a has transferred some of the momentum to b, so the momentum of b is changing and the momentum of a is also changing. Whereas if you take the whole thing, like whole system in count, then the total what you say momentum is not changing. Okay, so the total momentum of the system is not changing. In this case we are only calculating the momentum of this ball. I'm not considering the momentum of like the whole system. So what is the whole system? The whole system means the momentum of this ball with the wall. So if I would have taken the system of the wall and the ball, and then if I have calculated, then also the total momentum should be same. Okay, so in that case this is the thing ki, like for the total, if you calculate the total system's momentum, that will be conserved, but individual momentum of balls can change. So based on that we can study like the what you say collision theories. Now before we go into collision theory, we must know about what you say energies. So after we talked about energies, we can come to collision again. Acha, so this was all about your momentum conservation. So this momentum conservation can be used to solve many mechanics problem. Fine, and now we are moving to that thing which I talked to you earlier, and that was your what you say just a minute, I forgot it. So after this collision theory, we are coming to the friction. So it's a new thing about friction. What is friction? See, I'm talking about the origin of friction at first. So if I talk about the origin of friction, we know that smooth surface generally have less friction, whereas rough surface has more friction, right? So in that case friction is more, whereas in this case friction is less. But why? Now if I want to know why it is happening, then I have to zoom into the surfaces. Now we all know that when we have rough surface like this, if you zoom in, what generally happens in the uppermost of this surface, we know that every material is made of atom. So if you zoom here, you can see that we have atoms, and in that atoms the outermost orbits, in the outermost orbits there are some valence electrons. Now the far the more farther the electrons will be, and in that case the force which is attracting the electron towards the nucleus, that is because electron is negative and this is positive center, So that means this force will be weaker and weaker if we move to the farther and farther. So the farther the electron are staying, the weaker the coulombic force they are experiencing. So in that case, what will happen when the electrons are in the outermost orbit? So there they have a very less attractive force towards the nucleus. So that means they are loosely bound. So what happens generally, sometime it is possible for them to be ruptured from the bond due to this another surface. So when this surface touches this surface, in that case what happened, because of the roughness, what happened, sometimes some of the electrons can go to another surface. So as a result, what happened, this atom becomes apparently positive, and because electron is moving to the this upper another surface, so this atom becomes, or this pole becomes apparently relatively negative. So what happens, so this one is relatively positive and this one is relatively negative. So there is a coulombic force that attracts these two surfaces together. As a result, it creates friction force. So friction force is generally nothing but the coulombic force. What is coulombic force? Coulombic force is nothing but the forces between plus and minus charge base. Now so that is generally the reason behind friction. So if we talk about four fundamental forces, so friction comes under electromagnetic force. Okay, moving to the property of friction. So there are two types of frictions, generally not two types, we can classify it into three types. One is static friction. So we will generally read about this static friction. One is your kinetic friction. And one thing is your called rolling friction, that happens for your wheels. So in this all we will study generally static friction. Now what is static friction? Static friction means, let's say you have one surface here and you have a piece of block here. So if you have a piece of block like this above this surface, if you just blow air, do you think that you can easily move this block? No. Like if we just with some feeble blow, if we just try to move, it will not happen. So, but you know that when you blow, these air molecules go and strike this surface, right? Okay, let it be. Now if you try with your finger but with very feeble force, like very loosely, with very feeble force, if you just try to push it, you will see that at the beginning this block will not move. Now slowly you are increasing your force. Okay, so let's say this is the graph, and this is the what you say, this is slowly. So this one is your say your force, applied force, and slowly you are trying to increase the force, but the block is not moving. So you know that once you are applying force and the block is not moving, so the block is not moving means the total force on the block is 0. But if the total force of the block is 0 and you are applying a force F, so there must be an equal and opposite force that is acting on the block only. So this is not a reaction force, because reaction force works on two different point, right? Like the reaction force you will feel, but the block will not feel. But because the block is not moving, that means though you are using a force, that means there is another force which is acting in the opposite side, and that is equal also. So if only they are equal and opposite, then only this thing is possible, that is the total force is 0. Now slowly you are increasing the force and you see that still the block is not moving. So that means when you are increasing F, this frictional force should also increase in order to make total force equal to 0. So slowly you are increasing your force and friction force is also increasing. But suddenly you see that suddenly the block start moving after some portion, like after some limit. So after you reached here, suddenly the blocks start moving, and in that case the friction force will drop. Okay, so slowly you are increasing this force, like your applied force, the frictional force is also increasing. But after some limit, when you have reached some portion of like force, and then suddenly you see the block start moving, and that means the friction is now getting like what you say, friction is not increasing in that with that slope, it can decrease like this. So that means what happened, that means this friction force which was adapting with this applied force suddenly stops working after this point, and that's why the static friction has some limit, and that's why it is called what you say, limiting friction. So static friction is called limiting friction because it has some limit after which it falls down. So that means two things is clear. One, this friction force automatically adapts itself with my applied force. Friction force acts always in the opposite side of the motion. Okay, and the third point is that, see, why the friction force is happening, because of this surface. So that means this friction force works along the surface. So some points about this static friction is that like the friction which works when the like objects are stationary, that means when there is no relative motion between the surfaces. So I'm just pointing out some. So this static friction works when there is, when relative motion is not there between surfaces. So that is a first point. Second, it works along surface. Third, it works opposite of the motion, it works in the opposite direction of motion. Okay, till a limit it can adapt itself. And the uh, one more thing which I am going to write is little bit like can be what you say confusing, and that is that uh, this friction, static friction, does not depend on the area. Static friction does not depend on the, now this one uh, is little bit, because I already have told you that it happens because one surface when slides another surface it ruptures, like it what you say, it can take some of the electrons from the another surface. So that means this surface matters, but the like property which we have studied is says that the area does not matter. So what matters? Actually the thing is little bit complicated, and when let's say this is the surface and this is another surface, so you can see here the contact is not happening for all of the surfaces, right? Only some portion of the surfaces which is coming in contact with another one is doing the work. And one more thing is there, this surface, like one surface has to like push harder with another surface, okay, in order to like take like in order to take some of the electrons from that surface. So this is not basically very simple thing, but this is the property which we have studied. Now one thing we have seen that the friction will be called static friction till the time the object is not moving. Once the object start moving, then it is called kinetic friction, and that is different thing. So we are studying static friction, means the friction which happens only when I am giving the force but still the object is not moving. So in that case you have seen that the force and friction both are increasing together. So we have seen one thing, that this friction force is proportional to our applied force, okay. Acha, so it is increasing slowly, but after some limit it does not increase, so that limit we take as the friction force. So that is called the limit of the static friction, and that we represent like this, Fs. And we have seen this what you say, limit or the highest value of the friction for any surface is actually depending on the normal reaction of that object. So if you have one object here, so you know that this object is being dragged by gravity with mg force. As a result, this surface of the block is pushed with the surface of the table. So that's why table is also giving a reaction force, that is N, in the opposite direction. And we know that N in the in values, N is equal to mg, because equal and opposite force. So this N is nothing but your mg when it is like horizontal, the table is horizontal and the block is placed on it. So we can write Fs equal to mu s mg. Now what is this mu s? It's a proportionality constant and it is called coefficient of friction, coefficient of static friction. So this is it, and we have come till this much. That means your law of friction or some formula regarding friction. So now the thing is that why this like friction upper limit depends on this normal reaction. Now I have already told you that friction occurs because one surface is pushed with another surface, so they have to like interact. So this surface and that surface has to interact, but in order to make them interact, if I push this surface against this let's say I am pushing this A surface against B surface, only in that case this interaction can happen, and the electrons from one of the surface can come into another surface, and it can like create the polarities. That means it can create delta plus and delta minus charges, and that's why there will be Coulombic interaction. But if this push is not there, then it will not happen. So this push is given by your gravity. Generally, if you push, let's say if I have, you can try this in your home only, that if you have a block, so generally if you try your finger to move the block, let's say you have to give till 1 Newton force to move this block. But if you put some like one more finger and push this downside, you will see that now you need force more than 1 Newton. Maybe you need let's say 3 Newton force. That means the frictional force also has increased, and to overcome that you have to apply more force. Okay, so that means this push is needed. Okay, so this push will provide this normal reaction. Okay, so that's why this upper limit of friction force, that is the maximum static friction force, always depends on your normal reaction. So this was all about your friction, and in our next class we will talk about something more, and in our what you say online classes we will talk about we will practice and we will talk about the doubts. Okay, so till then, bye bye, and what to say, nothing.